Hello everyone, we are Group 8 and we are excited to introduce our project, Moodify. Our team consists of Ms. Zheng, who is responsible for clustering analysis, Mr. Liu, who specializes in sentiment analysis, and myself, who is in charge of designing the user interface. The inspiration for Moodify came from our team's love for music. With an overwhelming number of songs available on music platforms, it can be frustrating to find the perfect song that matches our mood. That's why we set out to create a song recommendation system that offers users the ideal song to fit their current mood, providing them with a more enjoyable listening experience. Moodify gets its name from mood and identify, and aims to recommend songs based on the user's mood. We use clustering and sentiment analysis techniques to categorize songs into 4 types. Let me demonstrate the system for you now. And I create a user-friendly interface using RShining that includes 3 sliders. Users can easily input their current mood level, the type of music they want to listen to, and the year of songs they prefer. For example, if I'm feeling down right now, want to listen to some romantic music from recent years, I can just set my preferences using the sliders. And then after I click the submit button, the system will automatically search for songs on YouTube and display the results for me. In this case, the system recommended Taylor Swift the last time for me. So let's go back to the slide. This is our outline. First, we scrape and clean the song data, and then we perform clustering and sentiment analysis. Finally, we will build a song recommendation system. We scrape the name of songs and artists from Billboard Hot 100 page from 2008 to now. We noticed that the leaderboard updates weekly, so we scrape the data of every week and remove the same song appears more than one time to ensure that we won't overweight each type of song. Finally, we got 7,500 songs data. This function is designed to scrape the data from each week of Billboard Hot 100 HTML page using beautiful soup. We package the data into a list of dictionaries and pass them to the next function. Combined with the previous function, this function scrapes the page of Billboard Hot 100 every week based on the time interval we input. After we input the dates and call the functions, we can print the dates to ensure that it works. The result should be like this. Then we scrape song lyrics from AZ Lyrics website. This is the function to scrape lyrics from the website. After inputting song and artist name, we will get a link of each song lyrics. It is worthy to mention that in the red box, we modify the song and artist name to fit into the URL format. And then we use the for loop to scrape every song lyrics. Also, we print out songs that fail to find on the website. This is the raw data, and we remove the sign like this to clean the data. Also, we only want to analyze English songs, so we use a pre-trained language model, fast text, to filter them. After tokenizing, we can show the frequency table of each word. And we modify some tokens by observing the frequency table. For the data preprocessing stage, we first add our customized stopwords to the spaCy package. Then we use spaCy preprocess function to tokenize the text, perform lemmatization, and remove stopwords. We only consider the verbs, nouns, adjectives, and adverbs in the text. After preprocess, we obtain the variable lyrics clean. Next, we calculate the TF-IDF scores using a feature set of 637 words. The following is the feature matrix that we ultimately presented. We utilize the k-means clustering algorithm to cluster the data. And with the assistance of ChatGPT, we determine the k-means function parameters to divide the data into 8 clusters. Upon comparing the outcomes of using both TSNE and PCA, we opt to utilize TSNE for our analysis. Here's the distribution of the clusters that we generated. And we also printed out the top 10 keywords for each topic. The number of songs within the cluster are shown in the brackets. It is noticeable that topic 0 and topic 2 accounts for the majority of the clusters. And the keywords for cluster 1 to 7 are quite similar. Presenting the high-frequency words of the 8 topics using a word cloud, we observed that only topic 0 has distinct category, which other topics appear to be not obvious. We are not satisfied with these outcomes. We utilize draw analysis to determine the optimal number of clusters, which was found to be 2. We named these 2 clusters as romantic and cynical. However, we were hoping to find more distinct categories, so we conduct sentiment analysis in the following.
In sentimental analysis, first, we calculate the smallest distance between each song and 2 cluster centers, and we normalize the values. Then, we can get output like this, from 0 to 1. If the value is closer to 1, then the song is more romantic than cynical, vice versa. Second, we use pre-trained sentimental analysis model TextBlob to rate sentimental score for each song. The scores are between 0 to 1, from sad to happy. Then, by setting the range and calculate the minimum distance, we can easily find the song with nearest sentimental score and genre score. Last but not least, we use web browser module to open the link of songs on YouTube for users and package all the code to our Shiny. And here comes the result. About the difficulties we've encountered, because there are 7,500 of songs to scrap, we got blocked by AZ lyrics a bunch of times. Fortunately, the block message only lasts 4 hours, so we can keep scrapping, but we still wasted tens of hours on this. To solve this, I think we can change the value in time sleep function to random integer to let us look like human. And that's all. Thanks for listening.